Hey everyone. My name is Tibor Korocz. Currently, I'm the Observability Tech Lead at Percona. I started as a MySQL Linux administrator and then MySQL DBA. Most of my career, I was a MySQL DBA working here at Percona as well. And then I transitioned to automation and slowly transitioned for monitoring and observability. And in this talk, we are going to focus or discuss how nowadays how AI is changing observability. What challenges that bring us, or how it's changing the field. Some of these. So this presentation is based on my experience and my research, what I did on this topic, conferences, what I visited, or product what I reviewed. Some of these are already used in different tools or in production. Some of these may be a bit futuristic, or they are going to be implemented in the future. Okay, let's dive in. First of all, what is observability? So if you ask, let's say, 100 people, what is observability? Probably you will get 100 different answers. But hopefully something along these lines. So observability should mean, or visibility, or gives you visibility or insight into internal workings, system or network or application or your IT architecture. And you can understand what's happening, how the different components connected, how the workflow, and it gives you some availability to solve and identify issues and problems. So far, so good. The traditional challenges with observability or back in the days we just called monitoring. Probably we all have been there once. You were sleeping in the middle of the night and you were just your phone just starting to get hammered by notification, text messages, alerts, all that stuff. First of all, you have to figure out if those are actual real alerts or those are not just some false positive or false negative as well. If you were lucky, those are not real alerts, so you will go back to sleep. But in the other end, if they were real alerts, you have to figure out what to do. So in the traditional way, you could easily get alert fatigue with too many alerts coming all the time, because workloads, systems and workloads are changing constantly. So fixed thresholds, they are not working all the time or hard to maintain. Root cause identification could take a long time. Traditional observability tools were not designed to today's workload or today's, not just workload, today's architecture. Back in the days when even the architecture were kind of, everything was in a silo, everything was running on one server or system. But that was true for monitoring. Anomaly detection could be challenging. Usually you had some static rules to see if, or maybe you were using some standard deviation to figure out if everything is in order or not. But as the workflow is changing, those rules may fail. And a few years ago, another player came into the picture. So the rise of the microservices. Now, as I already mentioned, back in the good old days, everything was running on one server. You had one server, you had the database, you had the web server, caching layer, everything was where it was easy to know where you have the issue because you had only one server. Then you had 2 servers, 3 servers, 100 servers, and everyone was connected to each other. All the application was running different places, connecting to different areas, and it was much harder to see where are the problems or what is causing them. Of course, that's introduced some challenges to monitoring as well. The monitoring solution had to also scale with this new changing of microservices and Kubernetes. Maybe just as one single node couldn't hold all the data what you were collecting from all these places, because actually now you are collecting much more metrics, not just metrics. You are collecting logs, you are collecting traces, you are collecting profiles, and all these things. Basically, you are getting a data overload. You are having so much data. It's too much to for a human to analyze and understand. Okay, so how can AI, but not just AI, machine learning, and LLM, large language models, help us? AI can automatically analyze a lot of data, a lot of metrics, can do anomaly detection, can help with alert filtering, etc. AI also can process not just metrics. LLM can also process log files, can understand traces, and can provide you recommendation or feedbacks based on what you can see in the logs and traces. AI can analyze your metrics of your workloads, your trends, your previous or historical data. Based on that data, it can give you recommendations for the future. Let's see what else can AI do for us. Can help reduce alert fatigue. It can reduce the noise. How many alerts do you get? It can dynamically adjust thresholds, or it can analyzing the trends and the workload, and based on that, on the historical data, you can train AIs, and it can adjust alerting according to that. That can reduce the number of alerts what you will get. And that's great because that means less alert. So the engineers can focus and spend more time on more critical problems, or just develop new features working with AI. Can also help us with the incident resolution. So we are collecting so much data, metrics, logs, profiles. We have hundreds of graphs, dashboard, and actually all this data is not helping. Sometimes it can hurt us. When there is an incident, we have to find the right dashboard to look at. Many times it's not that simple to find the right dashboard or the right graph or the right log. What can tell us what's the problem? It also depends on the seniority level of the engineer who is working on it. So if someone was working at the company for many years, based on past experience, he or she can probably easily find the right. But if someone just started few weeks, few months ago, maybe he or she cannot find that dashboard easily. Going to the documentation, checking what the documentation says, how can we solve this problem, how can we find that problem. Most of the time, in my experience, the documentation is not always up to date. So at the end, you just start looking different dashboards, and hopefully you are going to find the right. But here is where AI can help us again. So if there is an incident, AI can grab the necessary, relevant graphs, the relevant information, the relevant metrics, traces, logs, collect them, and give us, kind of lead us to the problem. So it can give us just the necessary information, where you can find what's the problem. That's going to bring us to our next topic. Why is that good for us? One of them is cost savings. Here I listed a few options, but in that case, one of the biggest saving what AI can give us is time. If identifying a problem, finding the right graph, right data, etc. If there is an incident, then maybe it's taking you have 15 minutes of outage. But if you can, with AI, if you can reduce or make that half the time, now you are going to find the issue maybe 5 minutes. That's going to save a lot of money for the business, and not just money, reputation. So saving time is basically saving money and saving. Also, AI can reduce the cost in a few different ways, like analyzing the data what you have, but not finding the data what you don't need, what you are not using, or using very, very rarely. So in that case, it can change the retention on that, change it, how many times you're collecting the data, could be metrics, could be logs, could be traces, whatever. Actually, Grafana has this feature, if I'm correct, it's in Grafana, it's called adaptive metrics and adaptive logs. And Grafana reporting, they can save some storage costs between 30 and 50% with this, which can be a huge number. Okay. AI can help with us with root cause analysis, for sure. When there's an incident, you're trying to find the root case of the, as I mentioned, AI can lead us, can gather all the necessary dashboard information for us. AI can analyze patterns, can identify patterns, and can find patterns what human cannot. Can analyze the dependencies between the different services. And it can provide all this information for you. And when you are doing the analysis, AI also can help you write your postmortem. When you're doing your analysis, probably your number one, or you're working on an incident, probably your number one priority is not focusing on the actual timeline or steps, or you're taking note what steps you are taking to find the problem and what happened. You are just trying to figure out what's the problem. You are trying to fix it as soon as possible. But AI can create you timeline easily, can gather all the necessary, or grab all the necessary data and information, can provide you a document, and at the end you can just maybe fill up the gaps or add more additional details. But it can give you a lot of help, and it's going to take less time than when you just write it by yourself. Big part where AI can help us is anomaly detection. Because AI is not just simply checking the metrics, or you're just collecting the metrics and sitting somewhere. Analyze those metrics all the time and try to find unusual patterns, unusual behaviors. Of course, this is also based on historical data. So it knows what was happening yesterday, a week ago, a month ago, a year ago. So it knows what should be, what is the expected output from the system. If something not right, it can alert you. So, and based on this, can change alert behaviors, adjust thresholds, and allowing engineers to basically act before the issue happens. So AI can provide you forecast of what's going to happen, or predict problems, let's say that, which is going to save you, reduce the downtime and save you from that. Okay. AI also can forecast the traffic what you are going to have. Of course, this is also based on our historical metrics and data as well, but it can, based on those patterns, it can predict the traffic what you are going to get tomorrow, next week, even next month. This can help you forecast your resource needs. You can adjust your auto scaling groups, how many servers do you have, and the resources what you have. This can also save you time. And okay, so far I didn't really mention LLMs, but LLMs can understand unstructured data. So it can analyze your logs, it can analyze your traces. And when you're doing your analysis, it can understand what you have in your logs. And based on that, it can give you recommendation, it can give you possible problems, possible solutions, and can help you to figure out what was really happening. Also, with LLMs, you can actually interact with your metrics. So with you can have a LLM chatbot where you are asking your bot, okay, how was the payment service behaving last night? There was any issue, any problems, etc. Anything out of the order, and LLM can understand that. So it can go check your metrics, logs, traces, and can came back to you and give you if there was anything or what happened. It can give you the timeline, can give you the issues, or it's just going to tell you everything was working perfect. So with this approach is not needed a deep understand on writing, querying your metrics, writing, creating dashboards, etc. So this is going to empower not experts to understand the data or interact with the data. What you can also have, it could AI could have access to your logs, metrics, traces, but it could also have access to your code base, like in GitHub, or it could have access to your tickets in Jira, ServiceNow, etc. So when there is an error in the trace or the profile, there is an error code, there is the line of the file where the error is. AI can go have a look, find that line, analyze it, and give you the issue, give you the answer what's wrong with the line. It could give you a recommendation. How can you change the code? How can you fix that issue? Maybe it can even make that change automatic. We'll see. What else could AI do for us in observability? I think soon, I think there is going to be a huge improvement in not observability per se, but in recommendation, actions, steps, what's AI going to give us when encounter an issue. We used to have steps to follow an alert, and when it was firing, we used to follow a documentation, but the documentation could be outdated, etc. Nowadays, many people even trust their life on AIs. Smart cars with AI driving assistance and automation. You're not driving anymore. You are observing, or in worst case, you are sleeping and AI is driving. So if you trust your AI with your life, maybe you can trust your website and an AI to fix an issue. So, or maybe there is going to be a rise of self-healing systems when AI notices the issue and fixes without human interaction. Okay. In conclusion, we are already having, but we are going to have more and more AI integrated in observability. It's going to save us time, resources, and probably going to save us the cost as well. For this presentation, I have a fun fact at the end. Actually, I was written 3 versions of this presentation. There was one written by me, and there was one written by AI, and there was one with, it's a mixture. So when I was writing this presentation about AI, I realized I could use AI to write this talk to kind of to prove a point to why we are using AI and how AI is working. So at the end, I provided my notes, 1 or 2 pages of notes to AI, which were created this presentation for me. Of course, I had to change a few things, but I was very, very surprised how good was the presentation, even with the presentation which was written by completely an AI just from one single question. Let me know, what do you think?